The essential questions for this lesson are: how is linear motion related to rotational motion, and how can rotational motion be used to simulate gravity? By the end of this video, you should be able to calculate centripetal forces and accelerations. The two equations that we're using are Fc equals mac, centripetal force is equal to mass times centripetal acceleration, and AC equals v squared over r. Centripetal acceleration is equal to the velocity squared divided by the radius. Our first question has a 900 kilogram car making a horizontal turn at 15 meters per second around a curve with a 32.5 meter radius of curvature. And we're asked to find the normal force, the gravitational force, the frictional force, mu, the acceleration, and the net force. Now, the easiest thing to find would be gravitational force, because we've been doing that for a while. So Fg equals mg, which is equal to 900 times 9.81, which is 8,829. which to three significant figures gives us 8,830 newtons as our gravitational force. Now this object is moving in a horizontal circle, so it is not accelerating upward or downward, so I know that the normal force has to equal the gravitational force, 8,830 newtons. Now the force of friction is the inward force, so the force due to friction is the centripetal force, which to find the centripetal force, we need the centripetal acceleration. So AC is equal to v squared over r. The velocity is 15, the radius 32.5, and when you plug that in, you get 6.92 meters per second squared as the acceleration. So 6.92 meters per second squared to the right, as this is drawn, or inward. Centripetal force is equal to mass times acceleration. So just like normal force is mass times normal acceleration, centripetal force is mass times centripetal acceleration. Mass of 900, centripetal acceleration, which we just found, 6.92, gives me 6,230 newtons. So 6,230 newtons to the right is my net force, which is also equal to the centripetal force, which is the force due to friction. So 6,230 newtons is also the force due to friction. So again, the upward and downward force are canceling each other out because it's not accelerating upward or downward. So the net force is the centripetal force, which is caused by friction in this case. Last, we have to find mu, the coefficient due to friction. Well, the force due to friction is equal to mu times the normal force. So 6,230 is equal to mu times 8,829, and plugging that in, we get a mu of 0.706. Remember, mu does not have any units. A bucket of water with a mass of 2 kilograms is attached to a 0.8 meter string and spun in a vertical circle. The speed of the water at the top of the circular path is 3 meters per second. So we're asked to find the gravitational force and the tensional force. Both of those are combining to give me the centripetal force for this example at this point. So again, let's start with weight. Fg equals mg, and mass is 2, 9.81 for gravity. Gives me 19.62 newtons for my gravitational force, which to two significant figures gives me 20 newtons. Now to find the tensional force, I need to know what the centripetal force is, because these two are going to add together to give me the centripetal force. So centripetal acceleration, v squared over r. V is 3, R is 0.8, so that gives me 11.25 meters per second squared as my centripetal acceleration, which I can now plug into my centripetal force formula and get 22.5. So my total centripetal force needs to be 22.5. But that centripetal force is made up of the gravitational force and the tensional force. So if we plug in what we had so far, 22.5 is my total centripetal force, 19.62 is my gravitational force. I can solve that for the tensional force, and I get 2.9 newtons. Notice if you add these up by themselves with significant figures, you get a little bit different of an answer here. That's just because of how we're getting our answer in the first place. That's just a significant figures issue. All right. Next, we have a 1.2 kilogram bucket of water held by a string and spun in a horizontal circle with a radius of 1.1 meters. And it gives us the speed of the bucket as 5.2 meters per second. Now, in this case, it's still a horizontal circle. However, it's being swung at an angle. So, again, if we look at the blanks, gravitational force should be the easiest one for us to find. Fg equals mg, 1.2 times 9.81 gives us 11.772 newtons. So to two significant figures, that gives us a gravitational force of 12 newtons. Now this is a horizontal circle, which tells us that it is not accelerating upward or downward. So the downward force of gravity must be exactly balanced by the upward component of the tensional force. So Fy must be 12 newtons as well, because it needs to balance out the gravitational force. All right, now we have Fx, acceleration, and net force. So acceleration is v squared over r. 5.2 is my velocity, 1.1 is my radius. When you plug that in, you get 24.5818181 repeating. So the acceleration, two significant figures, is 25 meters per second squared, and inward, as the picture is drawn at the moment, it would be to the right. Net force is going to be the centripetal force. Fc equals mac. Mass is 1.2, the acceleration that we just found. Gives us 29.49818181, etc. So the net force is 29 newtons, and again to the right as the picture is drawn, or inward. All right, so the net force is 29 newtons to the right. That's the x component of the tensional force. So I can plug in the 29 for my x component. The last thing I need to do is find this angle. I have the opposite, the Fy, and the adjacent, the Fx. So those are related by tangent. So tangent theta is equal to Fy over Fx. Fy is the 11.772 that I found earlier. The Fx, the 29.49818181, etc. Again, leave the entire number in your calculator, and then you're going to do second tangent to find the angle, and you will get 22 degrees for your final answer. Our last question doesn't give us a diagram. It says a 54 kilogram roller coaster passenger is moving so fast over the crest of a hill that she is lifted off her seat, and the safety bar exerts a downward force upon her body to keep her in the car. The speed of the car is 24 meters per second, and the radius of the curvature is 30 meters. Determine the downward force applied by the safety bar. So since we're not given a free body diagram, that's the first thing we should do. So we can just draw the passenger as a nice square. And I know that there's gravity acting on her, as well as the force due to the bar. which I'm just going to denote as FB. Now FB is really what I want, but those two forces together are giving me the centripetal acceleration. So again, find FG first, just because that's the easiest one to do. Mass is 54, acceleration due to gravity 9.81. I get 529.74. I'm not going to round this because the only thing I'm actually asked for is the force due to the bar, so this is not a final answer yet. Centripetal acceleration, AC equals v squared over r. It tells me the velocity is 24, and the radius of the curve is 30 meters. So when I plug that in, I get the centripetal acceleration of 19.2 meters per second. Plugging that into the centripetal force, Fc equals MAC. Take that number and multiply it by 54. I get that the centripetal acceleration overall is 1036.8. But that centripetal acceleration is caused by gravity and the force due to the bar. So if I plug in the Fc that I found and the Fg that I found, I can solve for Fb, and I get a final answer of 507 newtons. So remember, the two equations that you're going to be using for circular motion are Fc equals MAC and AC equals v squared over r. Now, multiple forces can combine to form the centripetal force, in which case you can find the centripetal force and the individual forces to figure out what the other that you don't know would be.